Assalamualaikum warahmatullahi wabarakatuh. We are from group 5 and we will presentation about Internet of Things or IoT for smart cities. And before we start the presentation, I will introduce our group members. The first, my name is Maulida, Nuzul, and my partner is Salsabilla, Armelia, Putri. I will explain the background. The background is the smart city concept highlight the importance of ICT to raise the city profile. A city can be called smart when investment in human and social capital and traditional and modern communication infrastructure promotes sustainable economic growth and high quality of life, with prudent management of natural resources through participatory governance.
Definition of smart cities. Smart cities use connect technology and data to improve the efficiency of city service delivery, enhance quality of life for all, increase equity and prosperity for residents and business. Dimension of smart cities. Stress the importance of the organic integration of the city's various system: transportation, energy, education, healthcare, building, physical infrastructure, food, water, and public safety, in creating a smart city. And then characteristic of smart cities. The most common characteristic of smart cities and emerging from this table are: first, a city's network infrastructure that enable political efficiency and social and cultural development. Second, an emphasis on business LED, urban development, and creative activities for the promotion of urban growth. Third, social inclusion of various urban residents and social capital in urban development. And the last, the natural environment as a strategic component for the future.
System component. First, overview of using AR to control equipment. The research was conducted to automatically control the tools that are usually controlled by using the handheld remote control. This control relies on infrared or ER radiation for communication with tools. Here, an ER-like emitting diode or LED on the remote control transmits the information retrieved by the AR received in the device. Second, Arduino is an open-source prototyping platform based on hardware and software once flexible and easy to use. This is a single-board microcontroller which is designed to make the processor of using electronic in multidisciplinary project is easier. The connectors are exposed on the Arduino allows the processor to be connected and to add an on module. Arduino is able to communicate with software that execute on a connected computer.
Third, system components. Raspberry Pi use an operating system based on the Linux kernel. Compared to desktop computers, Raspberry Pi is limited to RAM and CPU power. It can be connected to a monitor, keyboard, and mouse. This to connect to the internet directly and has storage facilities and an operating system. And then system components. Middleware. Middleware is a system that allows easy communication between things and humans through a number of protocols or communication channels, such as email, extensible messaging, and presence protocol or XMPP, hypertext transfer protocol (HTTP), Facebook, Jabber, instant messaging, MXIT, radio frequency identification, RFID, tag, quick response, QR code, short messaging service, SMS, multimedia message service, MMS, and Twitter. The main components of the middleware are controller.
Data analytics component. Data analysis is the process of checking, cleaning, transforming, and modeling data with the purpose of finding useful information, suggestion and conclusion, and supporting the decision. Implementation of smart cities. First, smart transport. The integrated transportation system will require one ticket in the form of a smart card can be loaded with money and swept at any point of entry to the transportation system using near-field communication or NFC technology to transmit information from the card to a reading machine and back. Payment is deducted accordingly from the card for the trip map. Second, smart tourism. A museum has augmented the reality system with QR codes placed at dots strategic in the museum. Visitor use smartphone to take picture of QR code. Every QR code link the phone to a URL providing details and the station of the museum where they are located.
Implementation of smart cities. Third, smart health. Mobile application, body area network sensor, and personal health management ecosystem have recognized as an essential component of the next generation healthcare technology platform because of their potential to enable citizens to play an active role in managing their health. Implementation of smart cities and the last smart home. The homes we live in can be configured to identify individuals. What they are is an ordinary family member, guest, or unauthorized person. Individuals are identified with what, why do they have in people. For example, smartphones that are identified by means of face radio. If an individual in the house does not have such an ID, then they are identified as invalid and an alarm signal is routed to the relevant external agency or to the homeowner.
Implementation of smart cities for smart home to control air conditioner. One of the features of a smart city is the optimal control of energy consumption at home while remaining provide comfort at the ideal temperature. The method for maintaining comfort at home is by adjusting the temperature through the air conditioner. This system architecture is experimental in providing just the right temperature for optimal comfort in a simulated indoor environment.
Overview of application used to control air conditioner. Application combine content rules that govern the decision taken on control smart house. It is thought that the application will also receive information from the electric utility regarding electricity supply and information from the weather bureau. The application then makes decisions on rules such as if the door is closed and the window is closed and the temperature is below a certain level, then adjust its air conditioning is appropriate. The ideal is to eventually be in a position to control the whole smart home environment this way. An explanation of the system image is as follows. First, passive infrared sensor to detect warm body once it is within range. Second, current sensor for measuring air conditioner energy consumption. Third, sensor to detect whether the door or windows is open or closed. And the last, air conditioner that can be turned on or off, or the temperature can be increased or decreased. The experimental result, the goal is that the sensor in the house are connected to the Arduino. The Arduino in turn connect to the Raspberry Pi via a USB cable. At first glance, the Arduino and Raspberry Pi perform the same function. Both are connected to the physical world. The difference is that the Raspberry Pi requires a lot more effort when it comes to putting together electronic circuits to connect to the physical world compared to the Arduino. Arduino functionality can be increased by adding a shield. The Raspberry Pi, however, has sizable processing power compared to Arduino. The Raspberry Pi connects to the internet via an Ethernet cable and then to the middleware. The middleware is software that translates between different protocols. On the other hand, middleware is an application that consumes data and sends instruction to the actuator controlling the air conditioner. Intelligence lies in the application for making decision making and air conditioner control.
Result table. I will explain the table. The Service structural health, network type 802.15.4, Wi-Fi and Ethernet, traffic rate 1 packet every 10 minutes per device, tolerate delay 30 min for data, 10 seconds for alarm, energy source mostly battery power, feasibility easy to realize but seismograph may be difficult to integrate with service with management Wi-Fi 3G and 4G, traffic rate 1 packet every hour per device, tolerable delay 30 minutes for data, energy source battery power or energy Heiferters feasibility possible to realize but requires smart garbage container, noise 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 monitoring 802.15.4 and Ethernet, traffic rate 1 packet every 10 minutes per device, tolerable delay 5 minutes for data and second 10 seconds for alarm, energy storage, battery power or energy harvesters, feasibility. The sound pattern detection scheme may be difficult to implement on constrained device, service city energy consumption, network type, PLC and Ethernet, traffic rate, 1 packet every 10 minutes per device, tolerable delay, 5 minutes for data, Tiger requirement for control, energy storage mains power, feasibility simple to realize but require authorization from energy operation, service smart parking, network type 800.15.4 and Ethernet, traffic rate on demand, tolerable delay 1 minute, energy storage, energy harvester, feasibility. Smart parking systems are already available on the market and their integration should be simple. Service smart lighting, network type 802.15.4 Wi-Fi and Ethernet, traffic rate on demand, tolerable delay 1 minute, energy source mains power, feasibility does not present major difficulties but require intervention on existing infrastructure, and the last service automation and salubrity of public buildings, network type 802.15.4 Wi-Fi and Ethernet, traffic rate 1 packet every 10 minutes for remote monitoring, 1 pack every 30 FT30 for in local control, tolerable delay 5 minutes for remote monitoring, few seconds for in local control, energy source mains power and battery power, feasibility does not present major difficulties but requires intervention on existing infrastructure. Experimental result of the table. From the table, it clearly emerges that, in general, the practical realization of most of such service is not hindered by technical issues, but rather by the lack of a widely accepted communication and service architecture that can abstract from the specific features of the single technologies and provide harmonized access to the service.
Conclusion. This paper discussed the application of IoT in smart cities. Application of ICT in service and urban infrastructure has changed the way cities operate and deliver service. Application domain for ICT in smart cities range from transportation to risk, health, the environment to ambient assistance, crime prevention, governance, infrastructure, disaster management, management environment, smart home to smart energy.
Suggestion. That is the paper author made. Hopefully, after reading and understanding this paper, readers can add knowledge about Internet of Things for smart cities This will add a reference to the about Internet of Things for smart cities. If there are suggestions and criticisms that you want to convey, please tell author.
So many presentation from our group. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.